So question number 1, true or false? Suppose a sample size of 87 was used to conduct a right-tailed hypothesis test for a single population mean. The null hypothesis was H0 equals 45, and the sample mean was 50, and the p-value was 0.03. Then there is a 3% chance that 87 randomly selected individuals from a population with a mean of 45 and the same standard deviation would have a sample mean greater than 50. Whoa, that's a lot of words, isn't it? Okay, let's try to lay this out. HO is the null. There it is, the null. The sample mean was 50. The p-value was 0.03. There's a 3%. Now, what does p-value mean? P-value is percent chance. Says it on the note. So let me write it down here for you. P-value. What is it? It's the percent chance that HO is true and results are due to luck. It's the percentage chance of luck, basically. That's what the p-value is. It's the percentage chance that it's just because of luck. That the H0 is really true and that you just got these lucky results. So that's, in this case, 3%. So they're saying 3%. There is a 3% chance that 87 randomly selected individuals from the population with a mean of 45 and the same standard deviation would have a sample mean greater than 50. Greater than 50. Yeah, right. That's exactly true. Right? Because that's what happened, right? They got a 50. The mean was 50. And don't be hung up by the greater than. It means 50 or greater. It's the same. It's basically the same thing. So yeah. So it's the chance that you would get that kind of a lucky result, right? They were testing something here, and the null hypothesis was 45. That the average, the null hypothesis, the assumption was that the average equals 45. But when they really did it, the average, the mean, came out to be 50. The results of their study came out to be a mean of 50. The sample, right? The sample results, when they surveyed a sample, came out to be 50. Well, that's what the p-value is. It's the percentage chance that that would happen anytime you do this, right? 87 randomly selected individuals, mean of 40, when their mean is really 45, right? The HO is really true, right? Their mean is, their average is, so if you grab 87 people who have an average that's really 45, so maybe this is their I don't know what, I can't think of something real life here that we would be measuring. Say you've got this whole gigantic population, and the average age, you got like 10,000 people at a stadium at a ball game or something, and the average age of the people there is 45. Suppose that's the real average for like 20,000 people at a baseball game, right? The World Series just wrapped up. At a baseball game, suppose the real average age for everybody in the whole crowd is 45. But if you grabbed 87 people at random, maybe you got an average of 50 for those people. Maybe the average age of those people were 50. You just happen to get a little bit of an older crowd. And so, for example, what's the chance that the real, if the real average, right? There's a 3% chance with the p-value is, there's a 3% chance that if you grab 87 people from a population, from the 20,000 or whatever, from the whole stadium, whose average is really 45, with the same standard deviation listed above, that you would have that you would get an average that's 50 or greater? What's the chance you would have such a high average when from your sample of 87 people, if the real average is 45? 3%. That's exactly what the p-value is. It's the percentage chance the results are luck. So that's true. They're saying exactly the right thing there. That's what the p-value is.